Hello everybody, glad to see you. Today we're going to implement GD&T for this component. In last session we have talked about reference features. We have talked about reference planes A and B and reference axes C and D. Now we are going to implement GD&T. Let's talk about this threaded hole. We are going to have 8 M8 here. We are going to use positioning. Based on reference frame, we need to use basic dimension. As we can see, this PCD, pitch circle diameter, is located in the box, and also this angle, it is in the box. We are going to use basic dimension for that. Back to BCD. As we can see here, we are going to have this table for M8. We can calculate LMC for hole. We are going to have this S. We are going to have this D. The average of that is 10.5. Let's consider 10 as LMC for hole. 10 minus this diameter is 2. It's going to represent total TZ. As we have talked about that, we are going to have 50 to 70% of total TZ for threaded hole. If we consider 50%, we are going to have 1. That's why in this box, as we can see here in second box, we are going to write 1 here for this threaded hole. Whenever we go to implement GD&T for this yellow component, we need to keep in mind we are going to have total TZ equals 2 for that. In coming session, we will talk about that. Here, we are going to have this table. This table was presented in session 16. Now we would like to have a nice profile here. That's why we are going to use this profile symbol here. We are going to have 2 datum references here, A and C. AA, we are going to have 8 reference plane A. Whenever we are going to have this profile by using basic dimension, it means we are going to control the size, location, and orientation for this profile, as we can see here. Let's come to this contact surface. We need to use location, orientation, and form. This surface is in contact. Let's consider 0.2, 0.3 as a TZ for that, for this common zone. And then for orientation, we are going to have 1 or 2 here. I'm going to consider 2 as a TZ for that. And then for positioning, I'm going to consider 3 here. That's why this dimension is in the box here. Back to B, because as we have talked, A is dependent to the B, and B is qualified by this flatness. TZ for that is 2. It is not in contact with anything. That's why we are going to consider 1 or 2 for that. Now I would like to talk about flatness. What we should write for flatness? What should be the TZ for that? As we can see, we are going to have a small and large values here, but normally we are going to consider 0.1 or 0.05. In this interval, we are going to consider it. It is related how we are going to make that component. We are going to use milling or lathe machine or drilling or saw machine. Based on that machine, we are going to have this flatness. Mainly, we are going to use milling or lathe machine. For that, we need to know what should be the RPM, what should be the feed, what is the material for that tool, what is the shape of that tool to make that flatness, and what is the depth of cut, and is it wet or dry, or is it cryogenic? And we need to know the accuracy of the machine. Based on that, we are going to define the flatness. But let's say it is 0.1, 0.05, something like that. How we are going to make that component. And also, we need to think how we are going to measure the accuracy of that component. We need to have coordinate measuring machine, let's say CMM. The accuracy of the CMM should be higher than the accuracy of the component. Rule of thumb says it should be 2-3 times greater than the accuracy of a component. If we are going to have 0.1 for the flatness, we need to divide it at least by 3. In that situation, we can see, okay, what should be the accuracy of that CMM. And CMM is not a cheap machine. We should take care about that. We need to know the application of that component. And based on that, we are going to choose a correct or good value for that, for the flatness. This CMM, based on the size of that machine and the accuracy of that CMM, it cannot be cheap. We need to take care about that. For now, I would like to close this session. In coming session, I'm going to implement GD&T for this green component. Thank you for today. I hope you enjoy it. See you next time.